So in the last video we looked at transistors as switches, but the name transistor refers to transforming resistance. So today we're going to look at transistors as variable resistors. So to do that, I'm gonna copy and paste the schematic that I have here and replace the transistor with a potentiometer, or simply with a variable resistance. Okay, that's not going to be that easy. Let's move it here and let's connect the slider or the center pin of the potentiometer to one of the side pins. Now let's put it there. Depending of the side pin we use, we get different results. So now we can scroll on the resistor and we can see the amperage change and get it close to what we have on this circuit over here. So that's the voltage we get at, that's the amperage that we get at 5 volts. Now I cannot connect this 5 volt power supply to the schematic because this is an example schematic and it would just short circuit it, as we just experienced. The simulation crashed. So let's restart the simulation and we'll get about the same amperage going through here. So if we input 5 volts, the NMOS transistor acts as a resistor with very low resistance. If we lessen the input voltage from 5 to, let's say, 4 volts, and just to mimic that, let's do it here as well, then the amperage goes down from 120 milliamps to 62 milliamps. So we can actually slide the slider a little to mimic that. The resistance grew higher because the gate voltage dropped down. It's actually not gate voltage, but the voltage between gate and source. So let's experiment with that. Let's drop it down even further. Let's drop it down to 3 volts. Apply and we get 22 milliamps. Let's change it here as well, also to 3 volts, and let's change the resistance. Now we have to change the resistance quite a bit to get 22 milliamps. Quite good. The slider used to be down here, but it has moved. We can see the resistance has grown when the gate voltage, or the voltage between gate and source, has gone down. Let's make it even less. Let's make it 2 volts. Apply and apply here as well. And we have 2 milliamps here, so we have to increase the resistance. We can see the resistance down here in the resistor parameters, and we have to look at the R1 values. So the R1 value right now is 460 ohms, and at 460 ohms we get 10 milliamps or 11 roughly, but we have to get 2.5, so we have to increase the resistance so the amperage matches up. Actually we can't, we only go up to 5 milliamps. That's because this resistor is 1 kilo ohm resistor, and we can't add extra ohms. So at this moment, this transistor has the resistance between drain and source roughly about 2 kilo ohms. And that's why we can look at transistors as resistors. Their resistance depends on the gate or the base voltage. Thanks for watching.